Hello, and welcome to another episode of AWS Tech Tales. I'm your host, Matt Burke.
And I am your host, Samara Reaño. How are you, everyone? Welcome to today's episode.
Everyone, say hi in the chat. Say welcome. Tech Tales is the show where we talk about real life customer problems and what you can do to fix them. Today, we're going to be spending some time on a favorite topic of the technical account management team here at AWS,
Yes.
which is resiliency.
Mhm.
What can you do to make your applications resilient? Now, maybe we want them to never fail, 99, all 5 nines uptime, but that comes at a price, that comes at cost. So how do you swing the pendulum one way
Mhm.
to have a very cheap architecture that may not be resilient to having a very complicated architecture that is very resilient within the region? That's what we're talking about today. And then next week, we're going to go even further on that journey.
That is correct. I think that one of our favorite topics to discuss with our customers as technical account managers is resiliency. And pretty much whenever we hear customers wanting to talk more about this subject, we always want to know what the use case, RTO, RPO, all of those little details that actually add up to really making sure that whatever it is that you're building in your environment is actually going to be built the right way to support the type of application or workload that you're trying to build out.
So let us know in the chat uh, that you're here, where you are, and what RTO even is. We swim in an acronym soup here at Amazon, so sometimes folks don't know what we're talking about, or they are like, "Oh yeah, I know exactly what they're."
Yeah.
Hey, Devin Bucks, welcome to the show. Thanks so much
Yeah.
for joining.
Thank you for joining today. Yeah, I would be curious to know. I guess, is that something that we kind of want to ask people about as we're going through our topic today? Or do we kind of want to test people out on if they know what RPO and RTO stands for and what we mean by setting those two?
We've got Kevin Buck says, "I get confused between resiliency and DR all the time." Me too. We have Zachary. Thanks for showing up. Thanks for coming. And Zubarali, Morocco, Ramadan
Oh,
Kareem,
hi,
welcome.
everyone. We have Sam as well. Hi. Thank you
Hey,
for
Sam.
joining, Sam.
Thanks so much for tuning in. So, Zamar, I have some good news for everyone that you and in the chat. We've
Okay.
all been hired as consultants for Unicorn Power Company.
Nice.
That is the tale that we're telling
Mhm.
today,
Mhm.
is the story of how we get from maybe a not so resilient architecture to something that can withstand some failures, and we'll try to experiment on those if we can, but that's where we're starting from today.
Hi,
Hey, DG
DJ.
Man. Oh, so
That's
yeah,
amazing. Okay.
I don't feel like I should just kind of give everyone the lowdown on what our new job is.
Yes, but before you kick it off, I would
Okay,
really like
please.
to remind people about our community page. So maybe we can pull that up, Matt. For those that are viewing our show for the first time, Matt are here every Monday, 5 p.m. EST, 2 p.m. Pacific. And for those of you that have missed the last couple of episodes, you can always go back to our community page here at AWS Tech Tales, and you will find each of the episodes that we have had in this season and in the past seasons all documented here, along with the show notes and different topics that we have covered.
Yeah,
That's
I
kind
owe
of what
some
I
show
wanted
notes
to.
here. That's why it's like my teacher just asked me to turn in my homework and I didn't.
That's okay. That's okay. They can always watch the past episodes, and then we can always catch up on the notes from the past, last week's one as
I
well.
promise this time next week we'll have the last 3 episodes on there. I swear.
Awesome. Cool. All right. So kick us off, Matt. Introduce what we are essentially being hired to do.
So we have a Unicorn Power account management app.
Mm-hmm.
And this app is here so that like everyone's got different meters. Like when
Mm-hmm. Mm-hmm.
you're getting a bill from your energy company, right? And they do a
Pretty much
meter
based on your your monthly consumption, pretty
Yeah.
much.
And so this is just an account management so that you can put in your meter readings, and
Mm-hmm.
then we bill you for it. So, you can register an account, you can put your email address in, you can put your name in, and then your meter ID, and then you can submit some information to us, and then we will bill you for it. Now, here's the problem.
Oh,
The app has gone down a couple times,
okay.
and the IT directors asked for a review. So I wanted to show folks what this application looks like,
Hmm.
and maybe the chat can help us understand what we can do to fix it.
Yeah,
What
like right off the bat, as you're seeing this architecture, I already know number one thing that I would be like, that needs remediation. But curious to know what our audience sees, like stands out the most with this type of architecture. I am assuming this will be critical, right? Because if you don't pay your bill, then you get your service disconnected. Am I in
Yeah,
the
this
right
is
track here,
mission
Matt?
critical. And I
It's
like
mission critical.
I like what's everything's in a single AZ.
Yes.
Yeah.
Yes.
Well, so that's a big problem here.
Yes.
Is we've got 4 different, and to kind of break down this architecture before we even get into the being mean, we've got 4 different ECS services behind an application load balancer.
Mm-hmm.
We've got our register and login. So you saw that functionality piece of on that page. We also have this view and update meter readings. We want you to be able to make a payment.
Mm-hmm.
And then, of course, we want to process that payment. And we've got an Aurora DB in that AZ, and then we got the NAT gateway. So everything's in a single AZ. I think right off the bat, that's a problem.
Right.
But why is it a problem? It's an availability zone. It's available. Why would, so this is like, you can index on cost, and look, I will be play devil's advocate here.
Mm-hmm.
Guess what? I don't have any data transfer between AZs here. So
Right.
I'm actually saving a lot of money.
Right.
I don't have to put any compute in there. But Sam's right.
Yeah. What if the AZ goes down? Yep.
Now, Samara, what does it mean when an AZ goes down?
Let's say there is service degradation in that specific AZ, and then you're kind of stuck there because you deployed everything in that one single AZ. So you have nowhere to fail over to.
Nowhere to fail over to. And I want to make it even clearer. Sometimes power goes out. Yeah, everyone fails all the time. Thank you, Devin Bucks. Sometimes the power goes out. And I know that it seems like a crazy thing to think about in the AWS cloud. But it happens. These things still, at the end of the day, are physical servers in racks in highly state-of-the-art, super cool data centers. But still, things are fail. So which is why we want to put things in multiple availability zones. Yep. So that's a one way to assess this is we've got one AZ. This isn't great. But what else can we think about? Like, what's good about this architecture though? I said, hey, there's no data transfer. What else? If my AZ goes down, get a corporate bankruptcy
attorney. First of all, in this specific scenario, you're going to have very mad customers. Let's say if they can't complete their transaction, they can't complete their payment, and then obviously they lose the service. One thing that I'm interested to know, right? This is kind of like the high level architecture. I would like to kind of know how, I guess, like the different components communicate what the flow of it is. Because that also has a lot to do in how you isolate failures. And that's kind of like one of the points that we usually also cover a lot when we're talking to customers about resiliency.
Yeah, it's great question. We can talk about the flow right here of what it's supposed to look like across that customer journey here. So you've got your user, and then they register, and then that's going to activate this register and login microservice. And then you can view and update the meter readings from here. So you submit the meter reading, or you can view what the meter reading was. Okay. And obviously the important part, making a payment.
Making the payment.
and we're processing that payment. So that corresponds to these ECS services that we've created here. But before I kind of dive into assessing the resiliency, what are some of the tools we can do that? I mean, some things we can assess off the board. I do want to ask again, what is good about this besides data transfer costs being zero? and by zero, I mean between AZs. Obviously, if you're going out to the internet here, there's going to be some data transfer.
Mm-hmm.
What's good about this? Anything?
Right. Let's see what the viewers have to say.
Is it? We've got some other databases here, and this is also
right.
fine.
We have the Dynamo, yeah.
But it's not necessarily sitting in an AZ, so that's helpful. But that's not what I'm looking for.
Okay.
I guess no. This is the answer, Devin Bucks. This is what I was aiming for. They're using an ALB, and what's good about using the ALB is that we can scale up and scale down. We have some elasticity. Mm-hmm. So if there's a particular failure, let's say within the service itself, let's say like you got, I don't know, a bunch of containers. If one of these goes down, at least we're okay. Cluster placement also is helpful.
I was going to say, yeah, that's another thing.
If you're using cluster placement groups, then, you're trying to co-locate this compute as close as possible. Maybe you want to make that transaction super speedy. That's also a great way to look at it too. So let's assess what the resilience is.
Okay.
Why not?
How do we do a check?
That? I'm going to use Resilience Hub, and it's a service we've talked about on the show before.
Mm-hmm. Yes, we have.
So we're going to just run an assessment. We're going to run this assessment and see how we're doing.
Okay.
So I'm going to add an application.
All right.
And
enter a description.
Unicorn Power. And this we don't need a description. It's optional. Let me make this a bit bigger for everybody. That's better.
That's great.
And I'm going to use resource collections because this architecture was built on CloudFormation. So that should make it a little bit easier.
And you have the collection already there for the CloudFormation stack.
So I should have a few of these. Build ECS cluster, databases, and then this one. Okay. So that should give me enough here.
All right.
And then what I want to do is choose a new resiliency policy. So what do folks think that I should, we just talked about, we kicked this off asking the question, what's the RTO RPO for this single AZ application? What do we think?
What do we think? Okay, so is your question, what do we think it should be in terms, because we know what the use case is here and what it's used for? Or is your question, what is RTO and RPO?
No, what it should be, right? If we know this is a mission critical application that's generating payments for our company, the Unicorn Power company, what should these targets be? That's an accurate assessment.
Okay. Curious to know what the audience thinks. What do you think it should be? I myself don't think it should be hours. It should be a lot less than that. It should be in the minutes.
So I'll create the resiliency policy. I want to call it mission critical.
Okay.
Can't type today.
Devin Buck said 15 minutes.
15 minutes is good. So let's say for the actual app, let's do 1 hour RTO but let's say 5 minutes, right? Because if we go 15, we go half hour, there could be payments that we miss,
Right.
which would not be good. And then
you have to update it. 5 minutes. It's an hour.
Oh,
from now.
yes.
Okay.
You're like, wait, don't do it before it's too late. And then for infrastructure, let's go even lower. Let's say it's 5 minutes for each of them.
Okay.
So this is if an incident occurred in the local error for an app component, and you can fix it by just like rebooting or replacing. So how quickly can we put another container into ECS for us? So that's where we're going here. And then the same thing for availability zone. And if I'm going to hold to this value in my infrastructure, I only have one AZ, so I might as well say the same for both of these. And then we're going to set up permissions because we have to then do the assessment. We're going to use this role.
Can you scroll up a bit where we were doing the AC specific? So for that one on the underneath it says region. When you check that off, what does that mean essentially?
So
it just gets distributed to other ACs within the region?
Yeah, so it's like, what's the RTO, RPO if something happens across all the services in the region?
Okay.
Which we will get to.
Okay.
One day, soon enough.
All right.
That's more aspirational right now, I think.
So we have the role.
We have the role.
Set up schedule assessment. Okay.
I'm going to add the application. So now we just added the application into Resilience Hub. We said, hey, here's the confirmation. Here's the targets that we've got. And now we're going to be able to import. So we imported these resource groups, and then we can publish and assess.
Okay.
So I'm going to hit publish and assess. This is version 1.
Oh, I love that you could break it down into the different versions. So it's good.
So, it's assessed. That was quick.
Well, that was really quick. I was about to ask you how long would it usually take. Never mind.
I mean, if it's a bigger deployment. Let's see. Review recommendations.
Okay. So you have your results, resiliency, and operational. So if you could just, like the overview.
Oh, it's still it's still in progress.
Oh, okay.
I was successfully obsessed.
Okay.
But it's
loading
loading.
Okay.
So we got tons of policy breaches. We'll let it load. We'll let it bake.
All right. Should have some elevator music.
I think we have some elevator music here. Hold on. I'll make it super low. But here. This is our elevator music.
Nice.
We refresh. Yeah, here we go. Policy breached.
Okay.
Results. It's unrecoverable. So we're not doing great, but except for infrastructure,
5 minutes.
5 minutes.
Yeah.
That was good from a recovery point objective. And then from availability zone, near 0 because there's only one availability zone. So we also can look around and see other recommendations. What does it tell us that we can do? It's saying our storage components. We've got our S3 buckets. NAT gateway. So it's basically all of the things that we've shown here. It's assessing. And you can see the current assessments for each of these. So this is a good sense of what can go wrong in this application. Now,
the current state.
The current state, exactly. And what's next, right? Well, you could for example, test these theories,
Mm-hmm.
test what could happen if something was wrong. So, we could do our trusty FIS, our fault injection service, and you could run some experiments here. I won't go into
Right.
them right now, but there's experiments that we can run to say we wanted to, for example, have a bad config on the ALB, right? Make something terrible happen here. We could check a code deployment from going wrong. So,
and I think that one of like the important things here to call out as well is that when you decide to conduct a file injection, simulation there, you already have those templates pretty much tailored to what the recommendations are under the Resiliency Hub, correct? They kind of give you like a way to test that within your current environment that you have been assessing.
yeah, so it'll give you some areas where it doesn't meet the policy or it does, and then you can use that to kind of build the experiments that you want to run, where you want to insert fault.
Right.
But now let's move on. Let's go a little further in the journey, because if we think about this architecture, this isn't typical. Like customer, I haven't seen a customer really index on, I want to be single AZ for a critical application such as this. Typically, we'll go to something that's more like this.
Right.
Which, what's good or bad about this architecture, folks?
So right off the bat, like one thing that I like a lot out of this architecture is that we have added CloudWatch alarms, which the previous one did not. It didn't seem that there was a mechanism to like alert other than maybe, them going back and seeing all the errors or whatever things were going wrong. But this is more of like an proactive approach where you're actually making sure that you're monitoring things in real time. And then, of course, that it's now across 3 different AZs, not just one.
I like that it's across 3 AZs. That makes it a lot more resilient, but it also makes it a lot more costly. Now,
yes,
I think that cost is worth the being able to sleep at night.
High availability. Yep.
But here's a question: where in this chart is bad thing is now money? Yes, for sure. And then no ASG, no auto scaling group. No, you can still auto scale within the AZ, so that's okay. If this is a critical application, we should explore incident detection and response. Well, that's a whole nother bucket.
Yeah.
We should actually, Devin Bucks, maybe I'll cue something up to dig a bit deeper into that next week. But bad thing is now money. So there is one bad thing on this chart. There is something that is not redundant. Can you spot what it is? The CloudWatch alarms caught my eye. Yeah, I'm sure.
All right. Any other areas here that would not be redundant?
I
remember from studying on my SA Pro certification, but I'll save it for the audience. Yes,
Sam is really killing it today. Yeah, this NAT gateway isn't redundant. So if you're going out the NAT gateway to the internet, data transfer here, that's going to cost you. But also, what if this whole AZ goes down?
Right.
How do I get out to the internet? I can't.
Yeah, you can't.
So, and this is something you can do, like just an architecture review. These are things that you could spot. Maybe they thought it was okay. The other thing here is that Aurora is in 2 AZs, which might be fine, but it's not in this third AZ. So you're gonna get some potential. Now I'm making a little bit of a crazy, but you're not gonna get any you're going to get a bunch of data transfer from here as well. So we're better. We're getting much better, but still there is some problems.
Areas of improvement. Yeah.
Yeah, there's still some areas of improvement. And from this point, besides this NAT gateway, which is kind of a glaring issue, what else could we do to make this more resilient?
So we have it now across 3 AZs. Can you think out there of another way that it could be even more highly available?
I do want to say the answer is not going to be add even more AZs. That is because I mean, this is deployed in what if the entire region goes down? Yeah, and so that's why the title of today is regional resiliency. We're getting ahead of ourselves. We want to stay within the region today.
Okay.
And the reason for that is most of the time you will too. That these fault domains are enough that if you're multi-AZ, that you can be generally like available. But that is what next week is for. We're to talk about what global resiliency looks like across multi-region. What are the services that we can use to assess that? And we'll play around and
so
have a bit of
today,
fun.
let's just think about the one region. Let's
just think about the one region.
Okay.
What else can we do here to make this more resilient?
Apart from the things that we have already called out.
Yeah, apart from the things that we have called out. And if we don't have an answer, that's good. That means that we're on the right track. Put DB and NAT in 3AZ. You're definitely fixing the NAT for sure. DB might be maybe a read replica if we need one. So I think that's in a good stage. What we'll do is come to this. This is our final regional architecture here, which I think Sam was saying no ASG. So we're adding a bit more auto scaling to this, and we're setting some specific parameters around it.
Is there any way that you can make that a little bigger, Matt?
Oh, can I make it a bit bigger? This isn't a PowerPoint, so
okay. No, if you don't, that's okay.
I'll read it out, which is that the usage levels are profiled, and then there's a desired and a minimum set, and then plus 50%. So you have static stability, and then you can react to service auto scaling to manage. So what we're saying is we know what our baseline is, and we can set this to a maximum that's 50% over. We've got a NAT gateway per AZ. So we got all 3 NATs here.
And we have Andres say maybe implement an LDB10 replies the instances.
Yeah, I don't know. I don't know what that means.
Maybe, give us more details around that. Yeah.
And
so we added 2 NAT gateways. We added CloudWatch Synthetic.
And so we'll go over these other pieces.
Okay.
Because what we want to do here is cross-zone load balancing has been disabled. Because what we want to do is do a zonal shift. So we'll talk about what a zonal shift would look like from application recovery controller.
Okay.
But I again, unless the whole region goes down, this is a pretty
we're pretty much there.
Yeah. And so even in this previous architecture, besides the NAT gateway thing,
you're
doing okay. I just want to point that out. But let's charge ahead and take a look at what the dashboards would look like for this.
Okay.
So I may have to go slightly smaller to do it.
Okay, so we're going back into the console.
And I'm going to go to CloudWatch.
All right.
Because really what I want to point out to folks is like, so that we have the architecture journey, right? Where we're looking at the architecture. This is a good question. How often does a region go down? What about AZs? Now, where you can find this out is the handy dandy status page.
Mm-hmm.
Now, it's not going to necessarily tell you how often, but it will tell you what was the history of the events, and you can get a bit more granular in your account health, like once you're logged into the status page. But this will give you a list of services across every region, as well as just a list of events. Mm-hmm. So let's give an example. US East 1 all the way back in July. So I didn't scroll that far and I hit July. Mm-hmm. We had some increased API error rates. So, and you can see like what happens. We give you a list of affected services.
Yeah.
And then we give you these
time over time as it progresses and the things that are being done to remediate.
And so this is an example of something that happened at the regional level. And really what we're saying is there's some error rates and latencies in the service APIs. So maybe for you, that might not be enough to shift to a different region if you're multi-region. Mm-hmm. But maybe for others it is. And you can see this lasted about 6 hours. So maybe you weren't having impact. Again, it has to do with the APIs as well. So if you have steady state running workloads that are immutable, maybe you wouldn't have felt it at all. And so these are the kind of considerations.
And then another thing that I want to throw out there, it's when you're monitoring this, another really way, another service to leverage and kind of have like a very good centralized way to look at all this is like using QuickSight and deploying the health dashboard. That's another great way also to concentrate on like one specific service or one specific AC region that you want to look at and kind of look back at the history. That's another great way to also look at this type of information.
Which, again, this was not the plug that I meant to do, but if you to go in a time machine back, wow, look at our faces. We have an episode directly on this about talking mm-hmm. about using Amazon Q mm-hmm. and using health events, and you can deploy also the health events intelligence dashboard.
Yep. Mm-hmm. And then also leveraging Heidi, which is pretty much something that you can use whenever those active events are taking place.
Is that the Cloud Intelligence dashboard or something different? It is something different. But again, all these dashboards are templates that we build on QuickSight mm-hmm. for your behalf using AWS data sources.
Yeah, so if you pretty much already have like the Kudos dashboard deployed and you are pretty familiar with the layout and how to interact, it's pretty much kind of like the same user experience when you deploy these other templates, these other dashboards that we're talking about. AWS Health Aware as well, I think, for notifications. Yeah, Sam, thank you for pointing that out as well.
Yeah, Health Aware is great. So Health Aware, you're going to get messages, like direct messages, email or Slack or Teams to alert you if there is an event. There's usually emails, there's usually big status pages in your accounts, but
right,
sometimes you're not looking, so you want to be able to understand.
Or you're managing you're managing an organization, and so it becomes too much to go one by one of your linked accounts to go through this notification. So it's kind of like a great way to just kind of aggregate everything in one specific place.
Question is, where are my dashboards? Let me find them.
Okay. It's on the top. It says dashboards.
No, I know. It didn't give me any.
Oh, it doesn't give. Okay.
Yeah, I didn't like that.
Oh.
Let me make sure I know I'm in the right region. Technical difficulties.
Where's your elevator music?
You can put it back. You can. It's the lo-fi music. Let me see if I got them in this region. Hold on.
Devin Buck says diagnosed with Amazon Q.
Not today. Not today. Here we go.
Okay. Oh, there you go. Okay.
So it's this is it's like, oh yeah, US East 2. No, I'm in Tokyo, guys. So pleasure of the
Okay.
demo. So this is our dashboard experience. I'm like, so there's this like there's the theoretical where we're talking about the what this architecture looks like, what it is. But what you also have to consider is, and this is kind of what I think Devin Bucks is trying to talk about with IDR, with incident detection and responses. You need to think about, well, what are the things that I want to monitor? What is the observability? And like, how do I create alarms that are meaningful, that are impactful, that aren't just noise? Because, you know, Zamar and I are both technical account managers. We see a lot of support cases. We see a lot of things going on day over day. We get a lot of no reply emails from AWS, and you just ignore them. You just stop looking at them. And that's not what we want in our monitoring observability. We want to be able to understand what's going on and take action quickly and sift through the noise. So that's what's going on here. So in this dashboard, we've also got these synthetics. So that's where we pulled up here. We have the CloudWatch synthetics.
Okay.
So it's not just customer data that's being generated. It's also these make payments, meter readings, and then logins. But you can see that meter readings going great.
Yeah.
Logins going great.
Make payment.
But make payment
Yep.
is not going well.
It's not going well at all.
So sometimes it succeeds, sometimes it fails, sometimes it succeeds, sometimes it fails.
And then it's also like a, it's a great way to kind of look at it as like a bottleneck of like a time of the day where everybody's just kind of trying to log in and do it at the same time. Or it's kind of like, just kind of try to isolate the pattern, right?
Yeah, exactly.
Devin Buck says, someone's dog is clearly excited with these CloudWatch metrics.
What we also have on this side is so this is customer experience, right? We're trying to see what customer are the folks that are coming to our app here when they log in, what they're trying to do. And then we also have, flipping through these. So we have both Canary success. We've got customer request
Volumes, okay.
So you can see we're monitoring the logins, the payments, processing and submissions, and then updates, like if I'm updating my meter.
Do we have one for, I was going to say, where are the failures? Like, do we have alarms for failures?
So we also have it by AZ too.
Oh,
so if we have critical failures, so for example, 2C had an error. We had a couple of these. So yeah, we're monitoring across the AZs too. So we're trying to pick up any patterns that could be the canaries in the coal mine, which is just a metaphor that everyone uses for this anyway. This is why they're called synthetic canaries. Which is Zamara, I don't know if I like that metaphor.
I was going to ask you, I have not heard of that. Like,
wait, canaries in a coal mine metaphors?
Okay. Yeah, no, I had not. So when I first heard about that, like, I had a question about it. I had to like go look it up. I was like, what is that? And then I was like, oh, interesting.
Yeah, a terrible metaphor. So just bringing a bird with you down into the coal mine, and if the bird dies, then you got to get out of there. Like, and then here we are today, and here's our canaries.
Wow. Okay, so healthy hosts, Aurora, ELB. So yeah, you pretty much have everything here.
So what you can see is what is alarming is my make payment is alarming. And the reason for that, obviously, is that some of these are erroring out. So my history is okay, in alarm.
An alarm.
So you can see there's a bunch of these that are in alarm right now. So that, to me, when I'm checking out my dashboards or if I'm getting alerts, that is what it's coming from to help me out. So if I want to dig a bit deeper into these canaries, I actually can go to application signals.
Synthetic. Okay.
And let me go back to the other region and see what happens. Yeah, there we go.
Okay.
See, this is where bouncing between regions. So these are the canary runs. This is what I've been doing in the background to try to generate what customer traffic would be to understand if something's going wrong. So a third of my actions have failed.
Failed. Yeah.
Here. So what we can understand is there's something going wrong with the payment method, but it's not, it runs sometimes. So this is really helpful where it's like, hey, it works for me, but not necessarily for everyone.
For everyone. Yes. So, what would you do next to isolate specifically what is airing out for some people? I mean, obviously, it's not something that is just an error across. It's only across in some cases, not in all.
So, which is a great question, because then it's, well, what would be the difference across, and where are we seeing errors? I'm good on USC 2A. I have a couple errors here.
Okay.
So I'm getting some errors like kind of across the board.
Mm-hmm.
So that doesn't really steer me. What are the best tools to monitor ECS Fargate containers? Is CloudWatch metrics enough? What I would say is there's additional add-ons for CloudWatch that you can use specifically for Fargate, and for ECS in general. It's Container Insights. So I can pull that up and then we can share it in the chat.
No, Andres also says, can you expand the time range? So he's taking a look at your different metrics and he's probably trying to pinpoint kind of like aggregate but a longer time frame.
Let's take a look. It might not go back as far as, how far does he want to go? 12 hours maybe? Like if it started at a specific time? That's an interesting. The other problem is when we're squeezing this much in here, it's a
lot harder to kind of like isolate it, right?
But to answer your question, here's what's interesting. Oh, maybe 24 hours. Yeah. So let's see how far back I can go. This got deployed sometime yesterday. So yeah, almost 24 hours. But what I do want to see under the 12-hour mark, or actually it loaded before.
And we have shared about the Container Insights for those of you.
Thank you.
So
folks, if you're just joining us, we're at the tail end of analyzing our resiliency for a specific application. It looks like this. We've got a multi-AZ application. We're just going through our CloudWatch alarms and our CloudWatch synthetics to understand what's going on, what's failing in this application.
And then just so everybody knows, we're concentrating on one specific region. So the answer would not be, we still need to kind of expand to a second region here.
Yeah.
That will be at a later day, another topic.
So it looks like USC 2C is the one that's being the problem here. Because I'm getting the alarm. There's multiple things that are in alarm here. There's updating the meter reading. There's the register and login. And the request counts are. So there's tons of different alarms. So this is like an aggregate alarm that's saying, hey, there's something wrong. So I think for our last piece for today
Okay.
is let's fix that.
All right.
Let's do what we call a zonal shift.
All right. So walk us through that.
So we're
So
going to
Route
go
53.
to, let me type in as arc. So Amazon Application Recovery Controller. This used to be Route 53, but now we kind of have our own thing. So let's get started here.
Okay. And so can you explain a little more of what the process is here? What's going to take place when you apply this Amazon application, the zonal shift that you're discussing?
Yeah, let me get into the right AZ. So let me make sure I'm in the right place. No, let me make sure here. Okay, no, let me do this from Ohio. Hold on. So what we want to do is essentially take our traffic and X out the bad AZ and shift it to these two. So basically marking this one as failed, right?
Okay.
So I'm going to do this manually. I'm going to do start zonal shift. I'm going to pick the AZ that's
that is
impaired.
failing. Okay.
And so I've got my ALB that's attached to my ECS cluster. And then you can set an expiration. So I can say, you can do this for 12 hours, 6 hours, what have you.
You can even do it a custom range. So
and then
you have
I'll
to
do it
choose one.
for 6 hours. And say 2C is having issues. So instead of it being this like manual process of like understanding like, oh, like what's even the problem? Which one is it? I'm seeing these failures. We already know based on our CloudWatch synthetics that, hey, 2C is having a problem, and I can just shift it away and give our folks some better
customer experience.
Yes, exactly. So that is what we're doing here. We did a manual zonal shift. This can be done automatically. You can create a custom configuration. So that's
so for the custom configuration, do you have to does it specify it, or is there a way that it could trigger automatically as soon as there is degradation for an AZ to just automatically pick whatever AZ that it is actually not working as it should? Or do you have to actually come out and manually call out that specific AZ?
So you can create a health check. So it doesn't right now it doesn't natively support ECS. So it'd be, we can't create our own integration, but you can create a health check, and then based on that health check, if it fails, then you can auto create a zonal shift.
So we have a question. Is this like an active strategy?
Yeah. So if you think of each AZ as an active, it's servicing active requests, then yeah, this is all an active strategy. Now, you could, for example, do this where this AZ maybe was a hot standby, so that you've got that extra capacity, but at the same time, can we review the target group health status post the zonal shifts? Yeah, let's go back to CloudWatch, and we've got about 5 or so minutes here. Let's see if within the polling time we can see that these errors start to go away. So I'll go back to last 15 minutes.
Dunko Cat ask if we have an auto configuration but all AZs are down, what happens?
That's a good question. If all AZs are down, it really depends on the failure mode of the application. Like, what does down mean? And I know that I'm like splitting hairs here, but like, is down mean that I'm having difficulties interacting with my application via API? Does down mean that that Godzilla went to AP Northeast 1 and took down Tokyo? Like, what does down mean? If there's no place to fail over for, then kind of, this is actually something that came up, funnily enough, in me studying for networking specialty. If all of your DNS entries are marked as unhealthy, then they basically are all valid at that point. Yeah, and then maybe fail over Route 53 record. But again, if all of these are down, then we're talking about a different story. But it does lead us into next week, where we'll talk about what that also means.
So stay tuned for next week, everyone.
Yeah, if this was interesting to you, stick around for next week's episode, as well as maybe we'll share the recording if you aren't able to make
that is true. Sam says to reroute to secondary region.
And that is where also, and I'll open it up in another tab so we can come back. Where application recovery controller excels. And that's more of the original kind of design, is to reroute traffic for failure from multi-region applications, and also do readiness checks to understand, like, hey, is this working properly? This was something that I've kind of seen the life cycle of, and so are you kind of too, like the life cycle of this being created and then being adopted over time. So let's see, is everything looking better now? Well, the good news is that 2C alarm is gone, but now 2A is in alarm. So that's not as good. But at least it looks like our payments are now 100%.
Okay.
And our make payment errors have gone down.
Yes.
So
look at that. Look how that flattened out.
Yeah. So that's good. But we failed over from that easy. We fixed that problem. But there might have been even more problems for us to solve that now we created. And it's really just the update, making a payment, and then update meters. So this is something that we kind of continue to investigate. But yeah, that's where we are with our architecture. Now, I guess the question becomes, what should we do to make this better? We talked a lot about multi-region. Where do we go from here? And let me pull up an example of what it'll look like as a preview for next week. But while I do that, tomorrow, check in with the chat, see if they got anything left before we start to wind down.
Yeah, we have like a couple of minutes, maybe enough for one or two last questions prior to us ending the stream. So for all of you that have been following along, any outstanding questions that you would like to address prior to us ending that have to do with the regional resiliency topic that we have been discussing today. And then also, if you want to have that deeper conversation about the multi-region, also make sure that you turn back in next week on Monday at the same time.
So this is where we're going for next week. This crazy diagram.
Wow.
So you've got the same, not only do we have multi-region, but we also have multiple application load balancers across those different regions. But otherwise, the architecture is
Pretty
pretty much
similar.
the same. But
Yeah.
I will say at this point, cost kind of goes
I was
straight
gonna
out the
say
window.
the cost is no longer a factor here.
Yeah. But that is the rub, is once you start to go to that point, it is
All right.
exponentially
We're at
more.
time, Matt. So thank you everyone today for joining. Appreciate all the comments, all the questions, and I hope to see you all next Monday as we tackle in another topic.
Yeah.
Any
So
parting words, Matt?
yeah, next week, tale of global resiliency. Again, we'll be talking about multi-AZ across the board. We'll take this architecture a bit further and kick the tires with some fault injection simulator and some more application recovery controller. So stay tuned, stick around. Thanks so much for joining, everyone.
Thank you, everyone.
I
Have
hope
a
you had
great
a good
week.
time. Have a great week.
Bye.